Oh, okay. Welcome to another session of bio. Today, we want to discuss RQ, respiratory quotient. What did I say? Respiratory quotient, RQ. It is still related to what we have earlier discussed on the respiration. Okay, respiratory quotient or RQ. Let's define it. RQ or respiratory quotient. Okay, fine. Yes, is a ratio. It's a ratio showing the relationship between carbon dioxide produced against oxygen used or consumed during respiration. That is RQ. That's the definition. Okay, let me repeat. RQ is a ratio showing the relationship between carbon dioxide produced during respiration against oxygen consumed or used. So RQ is given by the formula RQ, or respiratory quotient, is equals to CO2 produced divided by oxygen used. As simple as that. So RQ is equals to CO2, that is carbon dioxide, divided by oxygen. Many times students have a problem. They normally write RQ is equals to CO2 used or consumed divided by oxygen produced. What is respiration? Process by which food substances is broken down to produce energy, water, and carbon dioxide. So what is being produced? Carbon dioxide. What is being consumed? Oxygen. So it shouldn't be a big deal which one is being produced, which one is being used. So carbon dioxide is being produced, oxygen is being used up or consumed in the process of respiration. So that's all. So RQ is showing the relationship between CO2 produced divided by roll of oxygen that is consumed. How do you calculate it? Normally you are given an equation. Remember the equation of respiration shows on one side the food substance plus oxygen, and then the products are water, energy, and carbon dioxide. As simple as that. So if you are given a chemical equation, always there will be some values. There is a value before oxygen on this other side, and there will be a value before carbon dioxide on the other side. Another problem that also students normally make, or another mistake that they normally make, is that they try, I don't know if because of a lot of chemistry, they try balancing that equation. They get a number 98 before oxygen. They say 98 times 2 times 3 on this other side times. No. You give an equation that is balanced. This is biology. So the equation is already balanced. So RQ is among the simplest math I've ever seen. Why? You don't need to calculate a lot of things. You simply go and pick the value before oxygen, and you go pick the value that comes before carbon dioxide and substitute to your formula. Remember the formula RQ is CO2 produced divided by oxygen consumed. So you just read the value of CO2. If it is 102, you write 102. If this one is 98, divided by 98. You pick the values the way they are in the equation. Don't try to compute anything else. Okay. Now, the numbers that you get tells a lot. In another video, we've discussed about substrate. That's all. Discuss about substrate. And you said, what is substrate? The food substances. With that calculation, it can tell you what the food substance that was broken down. And the value that you get, I don't teach math, but I'm told ratios do not carry units. Okay? Do not carry units. So if that value is 0.5, just write 0.5. 0.7, 0.7. You don't add CO2 over oxygen. Okay? Yes, simply because in the process of division, the units cancelled. Volume of, if it is cubic centimeters, they've already cancelled. So it doesn't have units. Okay, that's the ratio. So if you calculate it and get a value of 0.7, it tells you that the food substances that was broken down was fats and oils or lipids. If you calculate and get 0.9, then it tells you that the food substance broken down was proteins. If you get a value of 1.0, that is 1, it tells you it was carbohydrates. So you see the importance of that RQ. Let me test you. What if you get a value of 0.6667? Where does it fall? Yes, you round off 0.7 about 0.7, and it is the food substance is lipids. So what is the significance? What is the importance of RQ? It is important for two reasons. Reason number one, I'd mentioned, but I'll repeat. One, significance of RQ. RQ, respiratory quotient, is important in that it helps us identify the type of food substance, the types of substrate that was broken down. How? If you get 0.7, tells you it is lipids. 0.9, proteins. 1, it tells you it is what? Carbohydrate. So 1, it is important that it is important in showing us the type of food substance that was broken down. Secondly, it shows the type of respiration. It shows the type of respiration. How many types of respiration do you know? How many? 2. Aerobic and anaerobic. Which one requires oxygen? Aerobic. Anaerobic doesn't require oxygen. Let's be practical. Let's go back to our equation. Okay, let me mention this first before I try to prove it in the equation. If the value is greater than 1, how are you talking about greater than? Was it the left hand? No, the right one. If the value is greater than 1, then it tells you that the type of respiration was anaerobic. If the value is greater than 1, 1.1, 1.2, 1.2, 3, 4, it tells you that is anaerobic respiration. If the value is less than 1, this is my left hand. The value is less than 1, it shows you that the type of respiration was aerobic. How? Let's use the simple value or values that, for instance, assuming amount of carbon dioxide produced was 100 cubic centimeters, and oxygen that was used or consumed was 50 cubic centimeters. RQ is equals to CO2, carbon dioxide produced, divided by oxygen consumed. So assuming carbon dioxide is 100, so 100 divided by 50, that's oxygen. It gives us a value of 2. So it tells you that it is anaerobic respiration. I said when the value is greater than 1, it is anaerobic respiration. Let's bring science into it. 50 was oxygen used, 100 was carbon dioxide produced. So in this process, less oxygen was used. Which type of respiration uses less or no oxygen? Anaerobic respiration. Are you getting that? Now, let's invert the numbers. What's it called? Reciprocal. Let's invert the numbers. Say that we have 50 cubic centimeters of carbon dioxide produced and 100 cubic centimeters of oxygen consumed. So how will our math appear? 50 of CO2 divided by 100 of oxygen. You get a value of half, that is 0.5, value less than 1. What does that tell you? Any value less than 1? Aerobic respiration. Bring science into it. When is a lot of oxygen used up? In which respiration? In which one? Aerobic respiration. So that 100 cubic centimeters of oxygen has been used, producing 50 cubic centimeters of CO2. So you get that? So RQ is important for two things. It shows the type of food that was broken down, the type of substrate, and secondly, it shows the type of respiration. So that is all about respiratory quotient, RQ. CO2 produced or oxygen consumed. Pick the values the way they are in the equation without altering anything. Just use for the calculation. No units, only values. Thank you so much. Nice time.